Yes. So let me just go to the crossout line, and then we go to what we really want to do today. So let me just bring in the crossout line to see how far we are. Oh, by the way, all are the other classes that you're attending? How are they so far? Do you have the problem with the class? With the other classes? Do you have the problem with this class? Do you have the problem with the material?
Sir, just practice. Like this a class, just more practice.
More practice, yes. That is why I wanted person to come in. Even last week, I was calling person to come in last week, Wednesday. And I didn't see anybody. Mr. Mackins was here as well, waiting for you guys, but we didn't see anybody come in next week. So we are hoping that that everything might be okay, so that you can come in this week. Right. So the lab is open. I'm ready for to accept you again next week, because you'll be doing some lab assignments, and I sent them off already. So I'm gonna look at them again. I'm gonna go through them to make certain that you understand exactly what you're supposed to do in the labs then. So let me just bring up the labs. Did anybody look at it? Look at the labs to see what you're supposed to do in the labs? All right, let me just
Sir, the information in the Google Classroom is, I find it very confusing.
Very confusing?
Yes, because it's like so much information from 2021. So no, I don't. You understand? To be honest.
I think I know you should talking. So let me just look at something a bit.
I'm not sure if I could hide some of the information and just show the relevant information.
Yes. All right. So I will do that. So let me just look at something first. Unit 1, basic electrical quantities and circuits. So we should be looking at our capacitor as well as inductor, because we almost finished resistors. Measure electrical quantities using ammeter, voltmeter, ohmmeter. So we're gonna looking at some ammeter and voltmeter again today. Ammeter and voltmeter, and how to use them so that when they come Wednesday, you actually know how to measure voltage and current. You have been measuring resistance, but you need to measure voltage and current for next class when you come to next class. So when you come Wednesday, you'll be getting the meters again, the multimeters, and you'll be putting on some current and some voltage and some circuits and doing some labs with them. All right. So let me just go right now to the assessment again and remind you. So you're supposed to get 3 labs, 1 test, and an assignment. I sent out the assignment already, and not everybody did the assignment. The labs, I sent out the lab, but persons seem confused about the lab. So let me just go on the lab and see if I can clear up what you need to understand.
The assignment, when you send that assignment, sir.
All right, so let me just go back to the assignment. Hold on. So this assignment was edited this one. Was it this one? This one. Which one I am I in? There's an assignment that I sent. Oh, that's what they were saying that I sent an assignment to the wrong group. So it looked like I sent the assignment to another group. Is another group I end up sending it to. Instead of this group, you're supposed to go and do an assignment. We look like it's the wrong group I send the assignment to. Let me see something. So this is the first assignment. There's another one that I sent. I sent an assignment. Oh, but it's the wrong place I sent it. Anyway, this right here, so this assignment, you're gonna do this assignment right here. So I'm gonna take out something out of this assignment. I'm gonna do this. So let me just take out some stuff out of this.
Okay, sir. When I sit there, can just please send it to our email, please.
Yeah, I can do that. So let me take out some of the stuff that's not supposed to be there. There's some students that we can't forget in all right, so this one right here. Let me just download this and put it on a different place. That you can get it, that it is a assignment, because all of those were material. So I'm gonna set this as an assignment now. Change the date and everything. Oh, okay. I figured that much. Well, this one should I do one? Sorry. I think that's the best way. But all right, so I'm right at the screen of the screen. The other issue. Yeah, that was a really good right to do it. So now let's try and see if we can get the semester over. Yeah. Well, now let me just stop here a little bit. I'll set it up properly. Yes, yeah. All right, so what I have to do then is edit the program. Let me just come out of this one. I have to get the beat from this one. So I'm gonna upload it now. The correct one. So I recommend that. Look at what happened. So if we read it, and they're no, just give me two, like about 1 minute to set up this. But out of two. But to reopen this one, but we're going to have to do two minutes. So I'm putting on the due date on it and everything now. This semester one, the end date right now is January 3rd. Put on the title now. So the best option, I think we can do another chapter. Honestly, going to do them on the side. I'm gonna put on the date on it, the due dates. So the due date for this one is supposed to be 15th November. All right. So let me just give it a topic as well. All right. So if you look in the group now, you'll see it assignment 2022. So let me just share this again now. If you look right here, it says assignment 2022, FOT, fundamental of technology. And the fundamental of well, this is supposed to change. Well, this one is not FO, this one is FOE. Fundamental of electronics. All right. So this one is fundamental of electronics. Assignment 2022, fundamental of electronics. So we click on it, you know, we see the assignment them. All right. So this is the assignment right here. We say draw a copper atom and label it. Hold on. So we did this already. No, it's in a school. All right, so question 2, write a list of resistor color codes that are shown here. So write the color code for a 4-band and its equivalent 5-band for a 10 kilo ohm resistor. Refer to the resistors below. If the resistors R1 and R2 are connected in parallel and is connected in series with R3, a voltage of 12 volts is connected for 1 minute. What is the total current? What is the charge in coulomb? What is the power dissipated through R3? Right? So that's all they're gonna do. And that assignment is supposed to come in the 15th of November, which is next week. Simple something. Simple something to do. Right? So when I come Wednesday, I'll give you the material and what you're supposed to do with material. All right. So let me just go back now to this part of it now. I need to go to the part of it. All right. So the labs now. So this assignment, don't watch this assignment down here, so you're not supposed to do this assignment. This is something different down here, so where you're not gonna concentrate on. So you don't concentrate on this. Concentrate on the one up here, so. All right. This lab now right here. FOE lab. So this is lab 1. Resistors. Use an appropriate table to tabulate all the results, given 2 fixed resistors, color code with colors brown, black, green. That's R1. R2, orange, black, and R3, brown, red, orange. Determine the resistance of each resistor. So you're gonna read the resistor color code. We're gonna do that again on Wednesday when I come Wednesday. Connect the resistor in series and calculate the total resistance. We practice that in class already. Connect resistors in parallel and calculate the total resistance. We practice that as well. Apply a voltage. I don't think we did put any voltage on it. We never put any voltage on it, so we couldn't see the current and the voltage drop. Calculate and measure the current through the resistor for each parallel branch. So this is supposed to change to resistor. So I'm gonna change this right here. So the resistor. So I'm gonna edit it and change it. Connect 3, give the resistor according to specification. Measure each resistor and write the value. Measure the total resistance, measure the parallel section, and write the value. Connect the voltage to the circuit and do the following. Measure the total current. Measure the voltage across R1 and the parallel branch and write the value. I don't know what the voltage is. So measure the current through each resistor and write the value. Calculate the voltage up and calculate I1, I2, and I3. For lab 2, this is capacitors. So you're gonna have to set up a circuit like this in the simulator. And I'm gonna put a battery on it and you have a capacitor in it and 2 resistors. And I'm gonna close S1, observe, and follow the instruction what you're supposed to do. Open S1, close S2, follow instruction. Close both of them, follow instruction, open both of them, follow instruction. And then it will tell you what you are supposed to do. Lab 3, inductors, electromagnetism. So lab 3 is about inductor or choke or coil. And you have to do some work here on them. So you're gonna use Tinkercad and electronic workbench and breadboard for actual prototype. Right? So to use a breadboard, which is a solderless breadboard, you'd have to come in to do that. So it is imperative that you all come in on Wednesdays to do your practical. All right, people? Hello?
Yes, sir.
Right. So without much ado, let me just go on to what I really want to do today. So I want to learn further how to use the tester to test current. I want to confirm that we know to test resistance and voltage. We're also going to be looking at one little calculation, how to calculate charge in a circuit. All right. So let's go to that. So we're gonna be using the Tinkercad first, because since the Tinkercad look more like what you really want to do, like the actual thing, the Tinkercad is like the actual circuit. So we're gonna log in into Tinkercad. I'm gonna learn to use the meter or the multimeter to do some testing. That means that when you come here Wednesday, you're not supposed to box shuffling. It's not supposed to be new to you. You should be able to use the meter, set the meter, do all this measurement, and then start lab 1 and get a select to do lab 2 and lab 3. By the time you come Wednesday, you'll get lab 2 and lab 3. So you're gonna get all the labs one time. So let me just put up all of this. We also will be looking at some resistor color code, because you need a resistor color code for lab 1. So we're gonna start off by doing the color code first for lab 1. But before I do the color code, I'm gonna show you a little chart so that you can refer to the chart whenever you are discussing the resistor. All right, so I'm gonna ask a question again now. What is voltage? What is voltage, people? Hello? What is voltage?
The flow of current.
No.
The flow of current, sir.
No, the voltage is not the flow of current at all. Voltage is not the flow of current. What is voltage, people? All right, what is current? If voltage is the flow of current, what is current? If voltage is the flow of current, what is current?
The flow of electron. All right, so in other words, voltage is the force that pushes the current.
All right, so voltage is the force that pushes current. So what is current?
The flow of electron.
The flow of electron. All right, and when electron flow, it usually flows through a medium, don't it? And the medium usually offers some opposition to the flow of current. What is the opposition to the flow of current, Carl?
Resistance, sir.
Resistance. All right. No, that's what I want to get at right now, resistance. So we're gonna look more at some resistance, especially resistor colors. We discussed that already from last week. So we'll be doing it again. You have been using it to do your calculation. So we want to confirm that you know how to read the resistors, the color code. We want to confirm it right now to make certain that you know how to read the color code. All right, so we want to bring up a blank PowerPoint slide. All right, so let me just clear off this one. Clear off this one and put my color code right here. Switch up my color code so that everybody is straightforward and know what they're supposed to be doing. All right. So look at this now. We're gonna discuss. Leave the silver and gold alone. We're not gonna discuss silver and gold. We'll be discussing all of this right here. So we know that usually when you have some resistors, and we know that resistor is the opposition to the flow of current. But when you're looking in some component, like this is a resistor right here. Let me just show you another resistor in a component. Show you another resistor in a component. All right, this is our system board. This is our motherboard right here. And we have some components right here. We're going to discuss all these components because as an engineering, computer engineering technology student, you have to know all of this that's going on right here. A regular computer person who does use computer doesn't have to understand these things, but you as a computer engineering technology student have to understand these things. So these are some resistors inside the circuit that are opposing current, right, for a particular purpose. Like this one is opposing a different current from this one. This one has a certain amount of current can go through this one, which is different from this. So we have 4 different resistors right here. 5 of them rather, and they are opposing different. They are allowing a certain amount of current to go through them for a reason. Like for instance, with this IC, it is obvious that this resistor is connected to this IC. It doesn't want a lot of current to go to this IC. So they put a voltage on it, and the amount of current that is going to this resistor is enough to run the IC without burning it up, because you don't want a whole lot of current to go to it. So this is all a set of resistors to protect different devices on a system board. All right, or an electronic board. So the resistor color now is designated that this. Black is 0, brown is 1, red is 2, orange is 3, yellow is 4, green is 5, blue is 6, violet is 7, gray is 8, and white is 9. We're not gonna discuss silver and gold, even though silver is 10% and gold is 5%. Right? So I'm gonna explain what that means now. So I'm going back now to Tinkercad. Going back now to Tinkercad. Right? I'm gonna take out a resistor in Tinkercad. And you know will tell me the value of this resistor. What's the value of this resistor? Oh, I still not sharing. I'm supposed to be sharing. Yeah, what's the value of this resistor? Yeah. This at the table. We know that brown is what?
1,
Black is what?
0,
Right. And red is what?
2, 0.
20. Yes. Instead of putting number 2, you're gonna put 20. So in effect, what's the value of this resistor?
1,000. 1,000.
All right. So if I get a tester and I put my tester on it, I'll get 1,000. So I'm gonna get a tester. And I'm gonna put my tester on it, and I'm supposed to get 1,000. Right? So there it is, 1,000 or 1, because it came in 1,000. All right. Usually when I test a resistor, you're not supposed to put in the power on it. Don't put in the power on the circuit when you're testing a resistor alone. It can damage a meter and damage. It can basically damage a meter. Basically. All right. So if I change this value, gonna be 10. All right. So let me just change it again and see what's the value of this one right here. What's the value of this resistor? What number correspond to yellow?
4.
4. What number correspond to purple? Purple is the same as violet. What number correspond to that?
That's 6, sir.
No, look at the chart. 7. So we have 4 7 and we have 4 0 right here. So this would be what would be the value of this resistor?
4, 7, 4, 0. 470,000.
407 or 470.
17. 4,
All right.
470 kilowatt.
470. Date is right here. All right. So they say we have 1 minute leave on the on the Zoom. So we're gonna stop and come back on right away. But I want all of you to come back on while here. So I'm gonna just stop it and come back on. All right.
All
I
right,
don't
sir.
want it to stop on me suddenly. I can get 40 more minutes to top it. One on. I'm gonna stop and come back on. Use the same link basically.